Hello. Hopefully, you guys are inside somewhere. Well, you would be inside. If you're outside watching this, you're weird. But um, I wanted to get this on video as soon as I could. So it's 7:20 Monday morning. My kids are watching TV. So if it gets a little louder, if they get a little rambunctious, I apologize. The focus for this lesson is to be able to, now that we've done some work with graphing sine and cosine waves when given the function, this lesson is more focusing on taking a graph that already exists and fitting a trigonometric model to it. So essentially writing the function for sine or cosine for what we're looking at here. And the first step to that, I think, is to ask yourself if you're going to use sine or cosine to do that, because you could use either, right? When you think about a sine wave, okay, what are you looking for first? You're looking for an intercept, uh, because that's where the period of a sine wave starts. So you could look at this graph here and say, well, here's a sine wave right here going from intercept to max to intercept to min to intercept. And that would be a sine wave that had been horizontally shifted to the left, right? But uh, that's a bit much, I think, because we don't necessarily need to do that. Um, if we look at how does a cosine wave start? A cosine wave starts with a maximum point, goes through intercept to min to intercept to max. So this, we would be looking at a cosine wave that actually starts where x is 0, and that's something that we're used to seeing. After we've established that it makes more sense, because we want to start here, right? We want to start where x is 0 because we want the period to not have a phase shift. We don't want to have to worry about shifting it to the left and right. When we think about the graph shifting to the left and right, that really messes with things, because when you look at that phase shift, that bx plus or minus c, okay, B does affect the length of the period. C does affect a horizontal shift to the left and right. But in tandem, when you have both of these things, it becomes really sketchy. And we've done some work with that. And we really want to try to avoid having to deal with both of those transformations. So what we're looking for is a graph that has its first critical point where x equals 0. So for this graph, it makes sense for that to be a cosine wave. Okay, so we've got the maximum happening here. So we know we're going to use cosine for this. Okay. After that, we've got to find these values of a, b, c, and d. Right. Let's in no particular order. Let's talk about the vertical shift. Okay. We talk about how cosine waves and sine waves have a midline. Okay. They have this sort of horizontal line that they're straddling, where the same amount of graph falls above as it does below. And when you look at this graph, you can see just by the eye test that the midline of this graph is the x-axis, which is what it's supposed to be. So we know that the vertical shift is 0, because if we were shifting this graph, we'd be shifting the whole thing up and down. Okay, we would be taking the wave and moving the whole wave up or the whole wave down, but that's not the case. So we have our vertical shift of 0 for this graph, and that's easy. That takes some of the stress off. Now, in terms of the amplitude, we've talked about the amplitude two ways. We said it's half of the distance between the max and the min. So we have the max up here at 3. We have the min down here at -3. That's a distance from here to here of 6. Half of 6 is 3. Okay, now we know this is a positive 3 because we are starting at the maximum. We are going to see some graphs where we have a minimum point here and then they rise up and then fall down. We'd still be using a cosine wave for that, but we'd have to take that number in front and make it negative, because we'd be starting at a minimum instead of a maximum. So we have the vertical shift not happening. We have the amplitude, which is 3. We know that the c value is 0 because the first critical point is where x equals 0, right? We don't have a vertical shift. Now, the only thing missing here is that value of b, and b is dictated by the length of the period. We had that formula, put this down here, the period is equal to 2 pi divided by b. So when before we knew what B was, we would fill this in to find the length of the period. Whereas now we know what the period is, but we want to use that to find B. So if we look at this, we remember a cosine wave is supposed to start at a max, go through an intercept to a min to an intercept to a max. So we've got one full period of this cosine wave from maximum point to maximum point, right? That is one period of this cosine wave. And it takes from 0 to 4 pi for that to happen. So that means the period of this graph is 4 pi. So we can set up a second equation over here where we say the period is 4 pi, and that is equal to 2 pi over b. And this, we have an equation here where we can pull the old switcheroo, swap the b out for the 4 pi, and we get 2 pi over 4 pi. Pi's will cancel. 2 over 4 is equal to 1/2. So we get a b value of 1/2 from looking at this graph. So in here, we're going to write 1/2 times x, but more appropriately, we would probably label that as x over 2. So we've got an amplitude of 3. We've got a period length that is double. So we're dividing by 2. Remember, whatever we do on the inside is the opposite of what you would expect to get this wave here. Okay.